Hello everyone, welcome to my YouTube channel Easy Programming. I am Naveen Mishra and I'll continue teaching you how to write programs in C language. In my previous video, I have told you about what are functions and how they work. In this video, we'll talk about inner functions, array to functions, how to pass array to functions and recursion. So let's start with this. Before starting this function, I would like to write a program for you guys. In my previous video, I have asked you to write a program in which three to four programs can be combined into one using functions. So I'll write this program for you guys. Program to implement functions. Header file hash include day.h main function. First of all, I have to create a menu so that the user can select any of the options from the available ones. So I'll declare a variable n and I'll say printf +1 for factorial program. Copy this code to save my time, and 2 3 4 5, that would be enough, and enter your choice. Then I'll say scanf %d comma and n. Then I'll create a switch function and I'll write the code here. Let me correct these things first. Fibonacci prime multiplication and press 5 for next. Okay. And when the user presses first option keys 1, I'll call the first function. So let's say my first function is factorial. So I'll create a function here. I want to create a function with return type as well as argument. So I'll say int factorial int n. I'll set a loop here for I is equals to 1, I less than equals to n, I plus plus, and I'll say I need another variable f whose value will be set to 1, and I'll say f is equals to f multiplied by I. Then whatever the answer is in f will be returned. Okay, I can put it inside curly braces. Just a second. There you go. Now I will call this function from here, in this switch case function. So first of all, I need a value to pass. So I'll say int n comma f, and I'll say printf enter the number of which you want to calculate the factorial. I'll say scanf %d comma and n, and I'll call the function factorial, pass the value n and read the value in f, and I'll print the answer here, printf slash n factorial of the number equals to f. There you go, and I'll put a slash n here. Let's try to run this program first. So compile and run. So this is the option. I press the 1 button, the factorial works. Okay, what about the rest of the other program? So I can do that as well. So I'll create another function Fibonacci series where I will have only arguments. So I'll say Fibonacci int n int a comma b comma c comma I, a equals to 0, b equals to 1, printf slash n Fibonacci series is %d slash t percent d comma a comma b. I'll start a loop with 1 I less than n I plus plus. Add the values, I'll print the message, then I'll swap the values. So, okay, that would work. So I have to include another case 2. I'll only ask the value here, so I'll copy this code and I'll say enter the limit point up to which you need series, and I'll call my Fibonacci function, pass the limit n, and I'll put a break. So let's compile and run the program. Okay, so it was previously declared, then it should work now. So I press the 2 button and the limit works. Like I say 10, the 10 numbers are printed to me. But the problem here will be I cannot continue, and I'll ask again the next output. So let's say I press the 1 button and the tutorial program works. After this, what I want is this message is shown to me again and again. I can pick any one of the option, and this continues as long as I press a 5 button. So what I have to do is I have to put it inside a loop. So what I'll say, I'll create an infinite loop like while true and put it inside a loop. Okay, everything will be placed inside the loop. Now the loop must have an exit condition. For this I have a case 5, so I'll put up case 5 here and I'll say simply exit 0, and I can put a default printf wrong input, wrong selection, try again, and let's try to compile and run this program. Okay, to work with the exit function I need a header file stdlib.h, so I will include this file stdlib.h, compile and run, and there you go. I press 1, factorial works, and then the message is shown to me again. I press 2, the Fibonacci series works, and so on. I press the 5 button and I exit from the program. So this is what I want to do, and I can continue remaining of my programs like prime number. So I'll say void prime. I'll keep it simple. In 10 printf, enter the number, scanf, d comma ampersand n, int I equals int I comma, that will work for I equals to 2, because prime number starts from 2, I less than n, I plus plus, if n modulus I equals to 0, I'll say printf slash n number is not prime, and I put a break statement, and if this condition never got hit, so I'll place if I is equals to n, printf number is prime, and I'll stop here and I'll call the case 3 here. So I'll say case 3, and I'll just call my function prime and put a break statement. Let me see that the other function name is right. Yeah, prime. I can create another program, void multiplication, multiply. I have to ask the value again, so I'll copy this code, save my time, and enter the number. I'll start a loop from 1 less than equals to 10, and I'll say r equals to n multiply by, well, I don't need this, printf slash n percent d equals to, multiply percent d equals to percent d comma n comma I comma n multiply I, and that's it. It should work now. Let me call this function as well. So I'll say case 4, I'll say multiply. Let's compile and run this file again. So there you go. Let me try all the functions one by one. So I'll press 1, there goes factorial, it works fine. 2, I'll say 10, Fibonacci series, it also works fine. Prime, I'll press 3 and I'll say 7, it is prime, yes it works. Then I'll say multiplication program, I'll say press 4 and I'll put a number 10 and there's a table of 10, so it works fine. And when I say 5, my program exits. So there you go. This is a large program where I have implemented all the programs. The first one, factorial, is with no return type with arguments. The Fibonacci is no return type with arguments. The first one was return type with arguments. This is no return type and no arguments, and same no return type with no arguments. So these are the programs that I wanted to, I expected you guys to complete it, but for you guys I have written the program here as well. So let's continue with next topics like inner functions, arrays to functions, and recursion. Recursion is very important. I'll cover this in this program, in this video. Let's start with nesting of functions. Similar to nesting of if else, similar to nesting of for loop, what we can do is we can put a function, one function call inside another function call, which will be called nesting of functions. So there you go. I have written a syntax here. First of all, main function will be executed. I have called a function, function2. So the control is transferred from here to this function, and this code executes. And here I have called another function, function1, and on clicking on this, it will call another function, function1. So main called the function2 and function2 further called the function1. So this is called nesting of functions. So you guys can write the program for this. I'll do this for you as well. Just a second. Let's write the program for this. I'll save my time here, and I'll not put a switch case here. Okay, and I'll remove all these things. Don't need this, and I'll put two functions. So I don't require these functions. Just a second. Now let's say this is my input function, and where I'm reading the values from user, and further I'll pass this value to whatever function I'm calling. Let's say factorial. So I'll pass this value, just a second, factorial, and I'll put a function here, factorial index. I don't need these values now. Start a loop of factorial like I equals to 1, I less than equals to n, and I'll do f is equals to f multiply I. So I need a f variable whose value is set to 1. I have to print the answer now, printf /n factorial of the program equals to %d. Sorry, I have to put the message number here, and I'll print the f value. Inner functions, I'll save the code with inner functions, and here what I'll do is I'll simply call my function which is input. Okay, so main function will call the input function will read the value and will pass this value to the factorial function. Now the factorial function will do the other task. So let's compile and run this file. Okay, I have to put this function definition above input function. Let's compile and run. I don't have any n, so I need an x here. Let's compile and run and put the 5. There you go. The program works the same way, but what I have done is I have called input function, which further calls, the control is transferred here, which further call the factorial function. The control is transferred, then here after executing we come back to this input function and then further come back to this main functions. So this is the practice of inner functions or nesting of functions. Let's continue with passing array to a function. Now in this program I am passing only one value like int x. I can pass two values like int x comma int y, but what if I have to pass the whole array? So I can do this as well. We can pass the whole array to function using arguments. So it should look like this one. When you define the function, in the arguments you will pass a array but will not pass any size here. This size will be dynamic, and when you call this function, whatever size this array have will be passed to this array. Okay, so this will be the how you write the program to array, passing array to functions. During call you have to pass only array name, you don't have to specify the size here. Okay, so let me write this program as well for you guys. Okay, in main I'll declare an array 5, put some values here. And I'll pass the whole array to the input function. I'll remove this function, and here I have to declare the array, so I'll say int x and empty size, and I can start a loop here now. So I'll say for I equals to 0, as array starts from 0, I'll to x and I less than, I don't know the size, so there will be a problem. So I'll pass the size here as well. So I'll say comma 5 represents the size, and we'll have a int size argument as well. And I'll say I less than size I plus plus, and I'll say printf element %d equals to %d comma I comma x of I. That should work now. Passing array, while and run. There you go, element 0 10, element 1 20. Let me put a slash in here so that you guys can see it clearly. So there you go. I have passed this value, this array, to this function, and this function have printed all the array size here. So this is the output. All right, so we can pass the array as well to the functions. Okay, let's continue further. Just a second, and let's see what's now the very important topic, recursion. So what is a recursion? Recursion is an alternative of iteration, and it is a special function that calls itself again and again until some specified condition becomes true. Now you see here in these programs we have called the function from main. The control transfers to this function, and after execution we return back to this function. What if I put this definition, I will put this call inside the function. Now the compiler will transfer the control from here to here. After executing these lines, the compiler will again see the function call and will transfer the control again here, and again the whole process is continued again and again. So recursion is a function that calls itself again and again until some specified condition is true. Whenever you implement recursion, you must consider two things. First of all, you must have an exit condition. If I do this, this will put my program in an infinite loop. There is no way that I can come out of this function. So make sure that you have an exit condition, as well as every call makes you closer to this condition so that you can come out of this function. So you must have two conditions there. Recursions are very useful in implementing the programs where we have to execute some code repetitively, like programs of factorial, programs of Fibonacci series, where we have to continuously multiply the numbers or continuously swap and add the numbers. We can do it using recursion. Recursions are very useful in implementing data structures like stack, queues, and linked list. Okay, but recursions is like handle with care, because recursion programs put your program in such a way that you will find it hard to implement and understand the program. So and also recursion uses more processor time. So make sure that before implementing the recursion you have in detail knowledge about how the recursion works. Otherwise you will have lots of problems. So let's start with some syntax now. So this is the syntax. I have called a function here in the 10th line. this function call transfers the control to the first line, and in first line I have, and in this definition I have called the function again in the fourth line, but I have put this function call inside a condition. So this call works continuously until this condition is true or false. Okay, now we talk about the programs of some recursion. So there are two programs that you guys can do by yourself. I'll implement the first program, that is factorial of number, using recursion. I have already written the program and I'll explain how the code works. So you see, this is the program code. What I have done is, in the main function I have asked input from the user in n, and then passed this n value to this recursion function factorial. So from 14th line my control transfer goes to this second line, and in second line I have put some code here. I have put a condition like if my n is 0, return 1, else return. I have written this code. So let's see how the things will work. First of all, you can see the output here. I have passed the number 4 and my answer is 24. The factorial of the given number is 24. Let's see how this coding works, how this output has come. Now you see here in the main function I have put a n equals to 4, as I passed the value here 4, and I have written this line. Now this line will pass the value of n, that is 4, to my function this in function body. In function body I have tested a condition like n greater than equals to, my n is equals to 0. In the fourth line I have put a condition n is equals to 0, but actually it is not. My n is 4. Since n is not equals to 0, this code 4th and 5th line will not execute, but 6th and 7th line will. Now what I have done in the 7th line is n multiply by, so 4 multiply by, and I have called the function again factorial. As you see, this matches, and the control transfer back to my function, but I have made sure that I can reach to this 0 condition by putting n minus 1. So my value of n was 4, and this 7th line what did is 4 multiply and call the function again, but this time with 3. And on seeing the 3, again it has tested the condition like 3 is equals to 0, which is false, and again else executes, and this time again n multiply by, that is 3 multiply by, and function is called again, but this time with 1 less, that is 2, and again n is equals to 1, which is not equals to 0. Again I have called this 1 multiply by 1 minus 1, and there you go, like and again n equal to 0. At the end my n condition matches and I have returned a 1. On returning the 1, I have come very far, I have come very deep in the box, so I have to return 1 by 1. First of all, 1 is passed to here, and this 1 is multiplied by this half written condition in the during the call. So 1 multiplied by 1 returned back to this 2, and 2 multiplied by 1 returns to this 3. 3 multiplied by 2, that is 6 multiplied passed to 4, and 4 multiplied by 6, 24 is passed back to my function, and in the f I have read this value and printed this value. So recursion is like opening the boxes inside the boxes inside the boxes. So I have opened this first box, then the second box, then the third box, then the fourth box, then the fifth box. I have written some value or fetched something from the box, then I have to wrap the box again. So I have wrapped this box, then again this box, then again this box, then again this box, and then again this box. You can simply say recursion work like a stack, like you have pushed the elements 1 2 3 4 5 and come back in the reverse order 5 4 3 2 1. So this is a program of recursion. I hope you guys have understood it and you guys can implement it by yourself. Okay, that's it from me from this video. Thank you very much for viewing my video. Keep on subscribing and sharing my channel. See you in the next video. Cheers.